Okay, welcome back. Here is the next installment on 2.5 Learning Outcomes, Simple Molecules and Covalent Bonds, Learning Outcomes 1 and 2. Here are the core concepts. Read through those. I'll read them quickly. State that a covalent bond is formed when a pair of electrons is shared between two atoms, leading to a noble gas electronic configuration. 2. Describe the formation of covalent bonds in simple molecules, including H2, Cl2, H2O, CH4, NH3, and HCl. And we're going to use an extra way of looking at this structure using the dot and cross diagrams to show the electronic configuration of these simple molecules. When we say simple, just single bonds between the atoms themselves. I'd like to pose a question, as I always do. Can you describe what a covalent bond is and give an example of such a molecule? For example, a covalent compound, a molecule is. And if you can finish that sentence off, great. Describe the formation of a simple covalent bond using a diagram. Can you do that? Slide 2, some general knowledge and information you need to know. Covalent bonds form between atoms of nonmetals. A covalent bond is a shared pair of electrons. The outer shells overlap so that each atom in the covalent compound gains a full outer shell of electrons. This leads to a stable configuration of that of a noble gas. A single covalent bond is made up of a pair of electrons. There are two types of substance with covalent bonding, with those that are simple molecular and those that are giant covalent structures that we'll see later on during this course of lessons. Here's an example. Covalent bond between a hydrogen acting as a non-metal in this case, plus another hydrogen acting as a non-metal, forming a diatomic molecule called H2. The other examples are F2 covalent and an HCl in its gaseous state covalent. Next slide on covalent bonds. Formation of covalent bonds involves the sharing of outer shell electrons only, as far as we know in the theory. Non-metal atoms share their outer electrons to form a noble gas configuration that is stable. We have a look at this example, hydrogen and atom bonding with another hydrogen atom. We can see by the use of a cross here, just circled here, that represents an electron, and then we add another hydrogen atom with its own electron here, which is 1 again. And then we overlap the outer shells, which is the first shell, and we get a full complement of electrons here, just highlighting here, and that is one pair of electrons equals one covalent bond. And it looks like the H2 molecule. Here's what it looks like without using the shells. Another way of representing it as a full structure. Go into more detail in some notes looking at the formation of covalent bonds. So looking at some covalent bondings that form single bonds. This is what we'll predominantly be looking at. Just a few notes here. In the covalent bonds, the atoms overlap their outer shells and share electrons. But in single bonds, each atom shares only one electron of its own with one from another atom. So in a single covalent bond, we have one pair of electrons share. Here's the example showing you what is happening in the ring structure, just with the outer shells, in this case, hydrogen, with its single electrons represented by the red cross there, and the blue cross there, or blue. Here what it looks like in the finished diagram. If they asked you to draw it, can you please put in the shared electrons? Here they are there at the top, and there's the single bond that gets formed, a single covalent bond. So there's the full structure. Here it is in a bit easier format that they may show you. Hydrogen plus hydrogen, single bond represented by this structure here. That's the horizontal line, so that's just a single covalent bond. We'll just finish it off there. We're looking at examples as per the syllabus with the hydrogen molecule here. So we're showing you some different ways of representing it. Here's the stick or line method we showed you before. Hope you're getting familiar with this. There it is. It's a hydrogen atom joining with hydrogen. We've got the single bond there. Here's the dot and cross method. You need to know also. So there it is there. The electrons represented here by a cross and a blue circle. Then here with the dot and cross method, we just show the outer electrons. In this case, the one shared from each hydrogen to give us one pair of electrons, which is a single bond. Here's the ball and stick method that we'll use with mods to show it a bit more three-dimensional, but here we've got more two-dimensional on this format. Here we go, hydrogen. Voila. Here's the next formation of a simple covalent molecule called chlorine, showing you in the stock standard forms of the stick or line method. So chlorine atoms joining up to form a single bond, just like the previous one, sharing of one electron on the outer shell. Here's the dot and cross method. So you can see here we've got 7 electrons here in the outer shell, and then 7 electrons here with the other chlorine atom. And then you can see that they share to imitate as if you've got a full outer shell of 8 electrons. So it's 1 electron shared, and then 7 from this chlorine, then 1 of the blue dots with 7 of the crosses to mimic a noble gas configuration of 8 electrons. Here's the ball and stick method, just to show you. That's the way you can represent it also. Okay, another version, slightly more detailed, a simple molecule, but it's a covalently compound molecule. This is water. We're showing you in the stick and line method first. There's 2 hydrogens joining up with your oxygen. Here's the jot and cross method. Remember, we're just looking at the outer shell electrons. That's got 6 and that's got 1 electron. So remember the rule. You can see it covalently bonded here. You can see hydrogen obeys the duet rule, which is 2 electrons. So it's got reached noble gas configuration. And if you look at the oxygen, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons, which obeys the 8 electrons, the octet rule, which is the full second shell octet rule. Looking at the final diagram, just to show you, ball and stick method, there it is. You can see the 2 single covalent bonds formed between the oxygen and the hydrogen in the water molecule, the bent water molecule. That's end of part 1. Please go on to the next lesson relating to this and start part 2.